So if you are someone who is preparing for the coding interview or grinding the LeetCode for some time, so you may feel like there are thousands of problems are there, and no matter how many problems you solve, once you see a new problem, you feel that it is a new problem and you are still stuck on that new problem, right? But what I have seen, so once they started solving the problem, and once after solving maybe hundreds or 200 problems, most people realize very important thing. So first is LeetCode is not about just solving the problem. And second thing they realize, so LeetCode is all about recognizing the pattern, right? So which pattern I'm using to solve any particular problem. In fact, most of the coding interview questions, they are actually testing you a small number of set or small set of the patterns, right? Out of that, they are trying to test whether you know and you are able to properly think and code or not, right? So in this particular video, we are going to talk about, first of all, top 13 particular LeetCode patterns, so which solves actually most of the problems or 90% of the LeetCode problems. So we are going to discuss, and we are going to talk about how to identify any particular pattern, and the most importantly we will talk about 4 pillars, right? 4 essentials, right? So which will help you to identify which pattern out of these 13 pattern or more patterns you will be using. So what is the best order to study them? So how many exactly problem you need to solve, right? What are the common mistakes people do? And you will get a full roadmap to start and empower your preparation journey. So in this video, you will actually understand the bigger picture of the LeetCode, right? So let's first understand the biggest mistake. So whoever is getting started with the LeetCode, they do is start with a random problem. So what they will do, they will just open the LeetCode, they will just take any problem, just solve it. In case they are struggling, they will just look into the solution, or they will go ahead and watch the solution in the YouTube or anywhere, and they will jump into the next problem. So this is what they will continue for longer period of time. So this looks like a productive session, right? Because they are solving every day, right? But this is not the fastest way, or this is the most slowest way to master LeetCode. Let me tell you what is the fastest way. The fastest way is that, first of all, understand the pattern very much or very well. Once you understand the pattern, so then what you can do, you can solve a couple of problems on the similar pattern and master that particular art of solving that particular pattern. Because after training this LeetCode from last 6 years and helping thousands of software candidates, so what I've seen is that, so most of the problems, so they are just not new problems. They are just a simple variants of the existing problem. So that means there exists a pattern, and there are small variants to that particular pattern, so that's how they are developing new problems. So this is basically what we can say 80-20 rule, right? Meaning 20% of the pattern solves actually 80 to 90% of the problems. So my recommendation is, instead of solving, well, let's say 500 problems, start with the pattern. Let's learn the important patterns and solve some of the problems related to that particular pattern, so that you can master that pattern and understand different variants to that particular pattern, right? And this brings us a very important skill in LeetCode, so which is the understanding or mastering the pattern or pattern recognition. So what should you do, right? So when you see a new problem, let's not start thinking about, let me try to code it, or let me try to think how to implement it, what are the edge cases. First of all, try to think, is it belongs to some pattern, right? Do I see any particular pattern involved in this? If you see it, then which pattern exactly it is? You might ask or think, right? So how can I identify the pattern immediately just looking into the question? Answer is remain in this question, right? Means whenever you see a new problem, just try to read it very carefully, right? So I am going to talk about 4 essential things, right? So now, so which you must read in the question, that will give you an idea which kind of problem or pattern you are going to apply, right? So like we are going to discuss 13 patterns, but which kind of pattern source I can expect for this particular problem just by reading the question itself. Okay, so I will start with the number 1 pillar or essential component, so which is the constraint, right? So you must read the constraint section, right? So for example, I'll take some examples and help you to understand. So constraint actually tell you that how much time complexity this particular algorithm you can maximum write, right? For example, let's say somewhere if you see your n or the input size is given less than 20, right? So that means what that means you might be using a backtracking algorithm or some brute force algorithm you must be using, which have a higher time complexity, right? Because that's why they have knowingly given you a n which is less than 20, so that you can use a complex, or I mean that kind of algorithm, so which is going to take more time complexity, right? So for small inputs, right? So if it is some small inputs less than 20 or something, then you might be able to apply the backtracking or some brute force approach. Let's say your n is little bit medium size, right? So if it is a medium size, then what you can do, you can think of writing any order of n algorithm, or even you can go for order of n log n algorithm. That means sorting could be a possible solution, or else you can iterate the input array one by one, right? So that's not a problem. And you can use all other important patterns like all other patterns or all other data structures like hash map, right? So dictionary or set, right? All these things you can use, or else you can go for the sorting if it is a medium kind of input size, right? But if it is a very high large input, right? So n is very high. So in that case, what you can do, you can think of, since it is a n is very high, that means you cannot even write n log n algorithm because it may take more time. So that's why you will start thinking about solving the problem in log n time complexity. Meaning, can I apply the binary search? Can I apply the maybe some tree, right? So tree with some balanced tree, right? Balancing tree or whatever, right? So, but ultimately the idea is if n is very high, so you need to solve it in an algorithm order of log n time, right? So that's what the motto I'm trying to say. So that will give you from the input itself. So what I'm trying to say here, so if you look into this constant very carefully, then it eliminates your lot of other applications or other algorithm which you don't want to use, right? So that's what is very important for you to look into the input or the constant section. Now, second essential component which you should be very careful while reading the question, which is the what is the input, right? Based on looking into the input, you can actually decide which kind of pattern or which kind of approach I will be using. For example, let's take a couple of examples and understand, right? So let's say your input is an array, right? If it is a simple array, so then what are the different patterns we know? We know maybe prefix sum, we know sliding window, we may know two pointers, right? So these are the couple of potential applications or the solution that you can think of. So let's take one more example. Let's say you saw a sorted array, right? So one sorted array as the input. Then obvious choice is you are going for binary search, right? Or else two-pointer approach, right? So two-pointer approach also can be helpful to solve the problems very efficiently, right? So that is also one more example, right? So for example, if you see another kind of categories of the problem like linked list, let's say your input is a linked list. If the input is the linked list, then you can think of applying maybe slow pointer, first pointer, or some other patterns which is involved in this particular linked list, right? So that's why it is very essential or very important for you to analyze or look into very carefully what is the input given. Okay, so if you talk about, similarly we can talk about trees, right? Like if you talk about the trees, you can talk about maybe DFS, BFS, or what kind of tree it is, right? So you are solving, right? So if it is in case of DFS, if it is what kind of traversal if you are doing in order, period, post order, depending upon that, you need to identify the patterns. If it is a graph, then you can say DFS, BFS, or else you are, if the graph is as the input, so then you will think that, okay, can I apply the DFS, BFS, or else can I apply the union and find, or else any Dijkstra algorithm I am applying if it is there is or else I am applying some shortest path algorithm, right? If there are some intervals are given, right? So in that case, what you can do, so you can also think about to solve this as the interval problem, right? So what I'm trying to say, if you look into this input very carefully, you will be identify what kind of pattern actually I'm going to use, because you will identify what topic it belongs to, and in that topic, what are the different patterns you have learned so far, and accordingly you can apply that particular pattern, right? And then let's come to the third essential component, so which is the output. If the program is, if you look into very carefully the output, what the program is giving you the output, then also you can also figure it out which kind of algorithm or which kind of patterns I am going to use. So let's say your output is like list of permutations or related to some of the combinations, right? If you see similar kind of outputs in some programs, definitely you can think of, can I apply the backtracking, right? So that could be one possible indicator that, okay, so you will be applying the backtracking, right? So if you say something like, okay, you are expecting having the maximization or minimization, right? And then number of paths, right? All these kind of categories or optimization problems. So then you can think of, okay, then definitely dynamic programming can be a potential candidate to solve that kind of problem, right? Or else you are expecting something like sorted as the output, right? So then in that case, maybe you can think of the sorting, or you can think of taking the like the heap, right? Something like that, right? So if the output is expected to be sorted, right? So then obviously we will go for some sorting algorithm or heap, right? That kind of algorithm or the patterns you can think of. So we have talked about three essential components so far, right? So which is the constant input output. Now I'm going to talk about the fourth one, which is very, very important. So which is the common keyword, right? So if you see these kind of keyword, definitely you know that which data structure or which pattern I'm going to use. I'll start with the maybe common example. Let's say you are finding the kth maximum, or you want to find kth largest element in a given array, right? When you see kth largest element, you definitely is going to think about the heap, because that is going to help you to solve the problem. So sometimes you see and keyword like longest substring, right? So if you see that kind of thing, then you can think of the sliding window, right? Sliding window is the appropriate pattern, so which you can use, right? So if you see something like next greater element, or you are finding the next smallest element, right? Then in that case, you can think of the stack, right? And it is specifically, you can think of the using the monotonical stack, right? So which help us to solve the order of one type complexity, right? So if somewhere it is mentioned that like connected components or number of components, or you want to identify different components or detect cycle, then answer is you will go for the graph algorithm, right? So I mean you will go for the union and find algorithm specifically. Somewhere if you see the keyword like merge interval, right? So do interval or find interval kind of merging, then obviously it is an interval problem. You can apply the interval patterns, right? So if you see somewhere the keyword like all permutations, all combinations, something like that, then obviously backtracking is one of the choice, right? So if you can actually master these four reading or essential component, actually you will be able to identify the pattern from the question itself. You don't need to think, hey, what is the n, value of n, whether there are some keywords, what is the input, what is the output. If you very master each and every problem and master this technique, then you will be able to essentially come out which pattern I am going to use. Now since we understand the four different pillar or the essential component, now we are going to talk about the 13 most important LeetCode pattern that is actually going to solve the 80 to 90% of the problem. So if you only master these 13 particular patterns, you are going to feel a lot more confident than you are right now. So before going to the discussing about the 13 patterns, so just one quick thing. If you are a software engineer who are really interested or passionate to crack the tier 1 product based company, so then go ahead and book a one-to-one call with me, so which is absolutely free, where we'll talk about your career growth and we'll create a personalized roadmap for you. Okay, now let's start with the patterns, right? So let's start with the first one, which is the two-pointer pattern. So in the two-pointer approach or the two-pointer pattern, so what happens? There are two pointers, as you can see, its name is representing, right? So whether there are two pointers which are pointing either in the beginning or end, or it can point to the consecutive, depends upon problem requirement. And they, let's say they are pointing to the beginning end, and based on some condition they are approaching to each other, right? So this is known as a two-pointer pattern. So when exactly you will use this particular thing? So if you see some problem, so where you are actually given a sorted array, right? So in that kind of problem, so then definitely two-pointer is a potential pattern to use, right? Or else you are asked to find the pairs, right? So you are asking, let's say, sum of pairs, or you are just asked to find some pairs which will give you this kind of two-sum problem, right? So I mean you want to find some pairs, right? So in case you want to find two pairs, then you can go for this particular two-pointer approach, the pattern. Or else if you are asked to remove the duplicates, right, from an array or something related to the same, removing the duplicates and all, then you can also think of the two-pointer. Or else if something is related to the palindroming problem, if there are palindroming problems, so then most likely you will be using the two-pointer pattern. So look for these kind of inputs, or like these kind of things, like if the array is in sorted form, or you are looking to find pairs, or is it a palindroming problem, right? Or you are deleting the duplicates, something similar, then definitely you can think of the two-pointer approach or the two-pointer pattern. Now let's come to the second one, which is the sliding window. This is also important pattern, right? So you must know this very well, right? So when to use this particular pattern, right? So this is commonly used whenever there is a substring, right? So you are asked to find the substring, or you are asked to find some subarrays, right? So subarray sum or minimum or something related to the subarrays you are asked, or else you are asked something like find the longest window or shortest window, right? Something related to that. So where there is a range involved, right? So what I'm trying to say, range involved, and there are some window is sliding, or you need to slide it in order to identify that kind of problem. So if that kind of things as given, right, so then definitely you can think of applying the sliding window. Now we are going to the third kind of pattern, right? So which is the binary search, right? So this is widely used, or when you will be using. So whenever you saw an input which is in a sorted form, or you are searching in a rotated array, right? Some problem they are asking you to search in a rotated array, or else they are just asking you to do this searching kind of thing, right? Or identify this particular element, right? So some searching technique you are going to use, right? So in that case, you can think of, can I apply the binary search somehow, right? Because if you apply the binary search, then you will get a more optimized or log-in algorithm, right? So that is a potential candidate in binary search here. Now after that, let's jump into the next pattern, so which is the slow and fast pointer, right? So this is very widely used in the linked list, right? Whenever you see a linked list, so suppose you are asked to find the middle of a linked list, then you can use this slow and fast pointer, or else you are asked to detect a cycle in case of a linked list, right? So that's a lot of problems you need to solve it. But in this kind of categories of the problem you solve, like in case of linked list, right? So then you can apply the slow and fast pointer approach for the pattern. So let's come to the fifth, right? So the fifth particular pattern, so which is the prefix sum. This is again another important problem, right? So when we use this, right? So whenever you see something like this, so when you see subarray sum, right? So you want to find subarray sum, or else range only, right? So you have some range, you want to find the difference, let's say. So from here, right? From the original, right? Subarray query problems. In that case, prefix sum is going to help you, right? So next pattern which is the sixth number pattern, right? So which is the enhancement or the frequency, right? So that kind of problem if you want to use, then you can use this pattern. In this particular pattern, so what exactly you will find it? So if you are asked to find a 2 sum or 3 sum, or find the anagram, right? Or find the frequency, right? Or find the frequency, or else find the anagram, find the duplicate, right? If you see this kind of terminology, then definitely hash map or the frequency, right? Calculate frequency map. So this is the pattern, so most likely going to be used. Now let's come to this, right? So next particular pattern, which is the seventh pattern we are talking about, which is this. So that means there are multiple patterns like this, right? So then like monotonic, right? But when exactly we'll think that okay, so it's going to be used, you see some problems like wherever there is a parenthesis kind of environment is there, right? Or if you are solving the next data element, right? Or something related to historical problem, right? Or somewhere you are finding the next maximum or minimum number. If you see this kind of problems, right? So then, or else design stuff using queues, right? So if you see this kind of problems, right? So then, it's going to be definitely a pattern is going to help you. Now we are getting into the eighth, which is the interval pattern, right? So this pattern, when exactly we will be using? So this pattern will be using wherever there is a scheduling problem, right? So you are doing some scheduling kind of thing, or else if you are doing some merging activity, right? So based on some interval, you are doing some merging and calculating based on that, right? So in that kind of problem, so you can use this particular interval pattern. Now let's jump into the ninth one, so which is the heap or the heap, right? So when exactly we are going to use this particular pattern? So this pattern is most likely used whenever you see, so you are asked like get minimum number, get maximum number, get largest number, or get smallest number, or else top k elements, right? So, or else median problem, right? If you see these kind of particular like abbreviations, then what you can do, you can use this particular pattern. So let's jump into the next pattern, which is related to the DFS, right? DFS pattern. So this is going to be a very, very important pattern. So this is used in a lot of programs. So like for example, if you talk about the tree traversal, so if you talk about the graph traversal, if you talk about the graphs, so a lot of programs are being solved using the DFS. If you talk about the island problem, right, so then you can apply the DFS. If you find number of islands also, then you can use the DFS. So if you want to find the path problems, like so if you see problem something like from here to there, you want to find the paths and all, then you can apply the DFS. So these are a lot of applications. So DFS pattern is one of the important pattern as well. So now obviously the next pattern which will come, which is the BFS pattern. So if some traversal is happening breadth-wise, right? So in DFS we are going in one depth, but here we are going breadth-wise, right? So once the one breadth of the level is completed, we are going for the next level of next breadth, right? So that means when exactly it will be used? So it will be again used in tree traversal whenever they see that there is a level of traversal, or else if you somewhere you see that there is a you want to find a shortest path between 2 points and all, then BFS will be helpful. Or else somewhere if you are saying that something is propagating, right? That means this is starting from the
vertex A on the top, then it will just propagate liquids corresponding down all the adjacency nodes, then it is going adjacency to adjacency. Because it is a level one, right? If something is propagating like a rotten iron, right? So if you know that particular problem, so I mean, if that kind of problem is there, so then we can use this particular BFS. Then coming to the 12th, which is the backtracking, right? So backtracking is very like exciting like problem. So if you solve, right? So whenever you see this kind of indicator like permutations, combinations, or else you want to identify all the subset of some problems, right? Or there are end-to-end problems, right? If this kind of problems is coming into picture, so then you can actually think about can I apply the backtracking pattern in this particular problem. So now we are coming to the last, which is the dynamic programming pattern, right? So it has a lot of applications. So what kind of problems so we can use? First of all, we need to identify a problem, so which is an optimization problem, right? So either it is a minimize something or maximize something. This optimization problem, answer is yes, we can think of like dynamic programming. And second thing is that whether we are able to reuse solutions. So we are coming up with some different solution where if you solve a small problem, so then we can solve a bigger problem, right? So if that kind of continuity is there, so then what we can do, we can plan for the dynamic programming. Or else if you are find the subsequence problem, right? So find the longest subsequence or each subsequence, if that kind of problems is also there, then you can think of dynamic programming. Or else some kind of categories of the problem like and all possible number of ways, like from A to B, right? All possible paths from A to B, or how many paths are from A to B, right? So let's say given a matrix, right? So if that kind of problem is there, so then DP is the candidate to solve that kind of problem. So this is the order also it should follow, because this whatever the order we discussed about, so this is going from the lowest complexity to the complexity, right? So you start from the easy, then slowly you will migrate to the complexity, right? Since you know the most common 13 patterns, so I want to just highlight there are couple of other mistakes what people do after knowing these patterns, right? So if you can eradicate or you can escape these issues, then you can actually fast track your preparation. So the biggest mistake we already talked about, right? So without knowing the pattern, so they will solve the random problem. So since you know this, just try with the beginning, like so 2 pointer or some kind of problem like that kind of pattern, and start solving the problem that way. And second mistake people do, so when you solve some solutions or solve some problem, right? So then they solve it, they try to memorize it. Okay, this is what happened, so that's why this is what this line I am using is using. So don't try to remember the solution, right? So try to analyze and understand why you use some data structure in that particular program. What is the significance of using that data structure? What is the pattern it is following under, right? So that's the most important question you should ask, right? Before actually memorizing or trying to digest that particular solution. So what another mistake people do, so they will directly jump into DFS or dynamic programming or backtracking without knowing the previous patterns, right? Because this is the complexity, right? So if you are not able to solve some basic patterns, then if you are going for backtracking, then obviously you are going to struggle. So then you will never go into a world where you will see, you will see that okay, it is becoming easy, it is making the life easier. So that's why it's very important, don't do this mistake. Start from the beginning, right? Start from the slow, easy problems, easy patterns, then slowly gear off and jump into the complex patterns. So avoid these points, like whatever we discussed, and you will definitely grow faster. So now to summarize this, so how the roadmap will look like? So roadmap will look like this. So first, you try to understand the pattern. Then second, so you need to identify how can you identify this particular pattern for any particular program. That should be your step 2. So once you know this, then try to solve maybe 7, 8 or 10 problems per pattern, right? So that's why you will know the variants of that particular pattern, because we discussed high level. There are little bit variants in 2 pointer, little bit variants in the sliding window, little bit variant in the prefix sum. So that's why solve approximately 7, 8 or 10 problems per pattern. So once you master this flow, then you can jump into the random problem or mixed problem, right? So that means you take any problem which is combination of 2 patterns or any complex problem, then you solve any random problem. Once you are ready, then definitely you need to go for the mock interview. and revise your common mistakes, right? So that's what you need to do. So if you follow this particular roadmap, so then your interview preparation is going to be very smooth and it is going to be very fruitful. So remember this what I started initially, right? So LeetCode is not about solving maybe thousands of problems. It's all about recognizing the appropriate patterns. So once you master these patterns, so then when you see a new problem, so that new problem is no more new to you because you try to understand what is the pattern behind that particular pattern problem. And once you identify that pattern, that's when this LeetCode and if you go for any interview, it is going to be very easy for you and you will love this particular journey. And if you are a software engineer who want to crack the your product as a company, then just go ahead and book a free one-to-one call with me where we'll create a personalized roadmap for you. So if you want to see one video, the hidden DSA patterns behind the tech company interviews, then I have created a detailed video on this. If you want, you can watch this video.